Hello. So the topic which I've chosen is projectile motion. Now, what is projectile motion? Well, just to simplify it, it is when a projectile, say a ball, is launched into the air. This ball is launched at a certain velocity and at a certain angle. Now, as you can see, the ball has covered a trajectory over time. Now, a few things to look out for in projectile problems is the distance traveled by the ball in this case, which is the range, the maximum height that the ball reached while in its trajectory, the initial velocity, and the final velocity. Since we are revising from 1300, we will neglect any air resistance. In any projectile motion problem, you want to first analyze the initial component, which is over here. This initial velocity vector can be broken up into two components: the vertical component and the horizontal component. Now in this case, the vertical component can be found using the formula V sine theta. Similarly, for the horizontal component, use the formula V cos theta. The horizontal component is independent of the vertical component, so these can be solved separately. When you bring the two solutions together, you get the resultant vector, which is the velocity in this direction. Now, if you look back at the trajectory the ball followed, you can see that you can break it down into the two components, the vertical component and the horizontal component. You can do this at any point along the trajectory. So as you go along, you will see that the horizontal and the vertical component always gives you the velocity at that point in time. Okay, so let's actually try solving a problem. Now, usually in a projectile motion problem, you'll be given either the initial velocity or the initial angle, the range that the ball traveled, or the maximum height that it reached. Over here, we're just going to put the initial velocity as 30 meters per second. The initial angle would go with 25 degrees. Some of the equations used to solve this problem are the following. Now remember to keep in mind that these can only be used when the particle is undergoing constant acceleration. The first equation we're going to be using is the following. It's going to be the vertical velocity is equal to the initial vertical velocity, one over here, minus gravity times the time that the particle is in the air. Now a few things to note here are why is the gravity negative? Gravity is negative because it acts downwards. So anything going downwards is treated as a negative. Anything going upwards is treated as positive. The second thing to note here is at the maximum height of the particle, which is h, the vertical velocity, the Vy, will be equal to 0. This is pretty obvious. As the ball reaches its peak height, the maximum height, it will stop. The vertical component will be 0, and it will start falling back towards the Earth due to gravity. Okay, let's start subbing some of these numbers in. So the velocity, initial velocity, is 30 times the sine theta. Theta is 25, and we'll end up with 12.68 meters per second for that. For the second one, the velocity, initial velocity again, is 30. This is the horizontal component, this is the vertical component, times cos 25 degrees, which gives us 27.19 meters per second again. So what we want to do now is just analyze the particle over here, right in the middle, where its maximum height is. So what's Vy over there? It's 0, because it's at the top. So we'll just go 0 is equal to the original vertical component, 12.68, minus 9.81 times the time that the particle took to get there. We don't know the time, so that's what we'll have to solve for. Now the time turns out to be 1.3 seconds. So what does this seconds actually mean? It means the time the ball took to travel half the distance to where the maximum height is, where the vertical velocity component is 0. So if we want the time for the total journey that the ball undertook, we will have to double this time over here. So the time total is equal to 2.6 seconds. Now that we've found the time, we can get to finding the range. Formula for range is R is equal to the horizontal velocity component times the time taken, total time taken. So if you recall from earlier, it's 27.19 meters per second times 2.6 should give you 70.7 meters. Finally, to find the maximum height that the ball reached, we're going to use the formula v squared is equal to u squared plus 2 times acceleration times the height. S in this case is the height. So v squared is equal to the vy is equal to 0, so that'll just turn out to be 0. U squared is the initial vertical component of that, which we found earlier to be 12.68 squared, and then the plus 2 times acceleration times the height. So since the acceleration is negative, we're going to go 2 times 9.81 times s, which gives us s of 8.19 meters. S in this case is equal to h. So it reached a maximum of 8.19 meters over here. Well, that's the end of this question. Usually in projectile motion questions, they'll give you either the initial vertical velocity, the initial angle, the range that it traveled, the height, or the time that it took. Most projectile questions are fairly similar, and they use the same type of equations. So once you get the hang of them, they're fairly easy.